In this video, I'm going to be specifically making it for my M105 classes at IUK. It will be covering section 8-1, solving quadratic equations using the square root property. Alright, anyone in an Algebra 1 or an Algebra 2 class can benefit from this as well, along with those college algebra students. Okay, so we're going to take a look at 3 initial examples here. Basically, square root property says that once you isolate your x squared term on one side of the equation, then you can take the square root of both sides. You've definitely got to remember to do the plus or minus sign on that right-hand side. Okay, so I'm going to take a look at this first equation here, and I'm going to see that there is a coefficient 3 in front of that x squared. I don't want that there. I need to get rid of it. So I'm going to divide both sides of the equation by 3. Okay, which most of us are going to be able to do in our head there, and we're going to end up with an x squared is equal to a 6. Alright, at this point, the square root property says that I can take the square root of both sides, alright, because those are inverse operations to something being squared. X being squared, square root would be the inverse operation. So when I take the square root, let's go ahead and write it on this first one. Let's write the square root over here, and then plus or minus the square root over here. Basically, there's our inverse operations. Okay, so the square root of that x squared gives me just the x on the left-hand side. Alright, and then I've got plus or minus the square root of 6. Alright, I can't do that in my head, so if you needed to round to a decimal, you could use a calculator to do that. Alright, your solutions should be checked in the original equation, always on these. Okay, so we'll do it here on the first one, and then I will leave the checking on the other two for you to do. Alright, if I take the positive square root of 6 and plug it in here, square root of 6 squared would be 6. 6 times 3 is 18, so the positive one checks. If I take the negative square root of 6 and I plug it back in, a negative square root of 6 squared would give me a positive 6. 6 times 3 is going to give me an 18. So they both do check. Alright, but you do need to check your answers. Now, depending on what class you're in, if you're in like a high school Algebra 1 or Algebra 2 class, writing your answer like that would probably suffice. If you are in a college algebra class, you're probably going to need to use set notation to denote your answer. Alright, which you could then use your set brackets, do plus or minus square root of 6, or if you needed to or wanted to, you could write them individually like square root of 6 and negative square root of 6. Alright, personal choice there. Maybe I probably should put the negative one first as opposed to the positive one, keeping them in order from smallest to largest inside that set notation bracket there. Okay, so again, on the second example here, we need to isolate the x squared term. So I'm going to add 16 to both sides of the equation. So I'll have 25x squared is equal to 16. Now I'm going to divide both sides by that 25. So x squared is equal to 16 over 25. Alright, at this point I can take the square root of both sides, adding that plus or minus on the right hand side there. I'm not going to show that line of work every time. So we will be down to x is equal to plus or minus the square root of 16 over 25. Alright, now at this point in M105 at IUK, we've already done our chapter on radicals, so we know that we can now separate those into two individual radicals. X is equal to plus or minus the square root of 16 over the square root of 25. This allows you to work them individually. That's going to give me a 4/5 there. Again, in a college algebra class, you are going to probably want to use that set notation for your answer as opposed to just circling this. Okay, but just depending upon what's required for your individual course. Alright, so let's do one more here. I don't know that you would encounter this in an Algebra 1 high school class, but you'll definitely encounter it in college algebra. If we subtract 25 from both sides on this one, we'll have 9x squared is equal to a negative 25. Alright, and we'll need to go ahead and divide both sides by 9. So x squared is equal to negative 25 over 9. Alright, again, not showing that step, but taking the square root of both sides, I'm going to have x is equal to plus or minus the square root of a negative 25 over 9. Okay, now, assuming that you have worked with your imaginary numbers here, square root of a negative number is going to instill that imaginary numbers, or you'll have imaginary solutions. So, the easiest way to do this, so that, some people just automatically do it, but a sense of what you are doing. I can multiply two radicals as long as they have the same indice and have the same thing. So if I separate that into, say, the square root of a 25 over 9, all right, times a square root of a -1, that lets me pull that -1 out so that I can clearly see that this is going to be where my I is going to come from. I can do this like normal because that's going to be a 5 over 3. All right, if I wanted to show that individual step there of separating out those radicals, I could. All right, or I wouldn't have to. So x is equal to plus or minus 5/3 I. And again, in your set notation, plus or minus 5/3 I. So either that or that for your answers. Okay, so 3 actually pretty straightforward examples of how to use that square root property. You definitely have to isolate the x squared term by itself before you take the square root of both sides. Definitely thanks for watching. If the videos are helping, don't forget to share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.